All right, so these are the notes for graphing quadratic functions in intercept form. So far we've talked about three forms, or this will be our third form. So the first one was standard form, which is y equals ax squared plus bx plus c. And I knew this was a quadratic function because I can see x is directly squared. But you do have these letters a, b, and c, and we talked about what those do. The second form we discussed was the vertex form. And I like the vertex form because the first thing you should be able to get out of the vertex form is the vertex, right? So that makes sense. H comma k is the vertex. Now the one we're learning today is the intercept form. So for the vertex form, the first thing I grab is the vertex. For intercept form, the first thing I'm going to grab is the intercepts, right? But let's talk about this. So standard form, x squared, that's obvious, it's a quadratic function. Vertex form, x minus h in parentheses squared, so x is squared, that's why I know that's a quadratic function. For the intercept form, you'll notice there is no x squared, but if you think about it, when there's parentheses, you multiply, so x times x is x squared. Okay, now, the a value, that hasn't changed, right? If a is positive, we know the graph's going to open up. Oops. It opens up. If it's negative, hopefully by now you know it opens down. Okay, now, the things I need you to get from this form, okay, intercepts. So pretty much you solve them, right? I could take x minus p, set it equal to 0, and solve. So I would add p to both sides. And x equals p. So pretty much you just take the opposite of what you see. It's better if you just set it equal to 0 and solve it, because if there's ever a number in front of x, you would divide, not forget that. So here I'm going to write it simply as intercept form, or as intercept. So if I solve, then I got p, this would be p comma 0. Over here, if I solve this one, it would be q comma 0. Okay. Axis of symmetry, the formula for this is this. X equals, you take the roots, p and q, you add them together, and you divide it by 2. Because we know that the vertex by now, the axis of symmetry splits the graph in half, so the vertex is that point at the top or the bottom that does split it in half, okay? So pretty much you just take the roots, add them together, and divide by 2. Okay, so let's take a look at an example here. So we can tell this is a quadratic function because x times x is x squared. And the first thing we're going to do here is we are going to find our x-intercepts, right? So right here, it was x minus p, x minus q, and then we just pretty much switch the sign. This becomes positive p, comma 0, positive q, comma 0. So right here, since I have x minus 3, if I set that equal to 0 and I solved it, I would add the 3 and it would be 3. So I would get 3 comma 0. So the other one, just flip the sign, but always be cautious in case there's a number in front there. But this one is going to be 7 comma 0. Okay, so now we have our 2 roots. Direction, a value is 2. So I can see that a value, it doesn't change. It's positive, so it opens up. Okay, if I wanted my domain and range, I could do the domain, but the range, I'd have to have the what is it called? The vertex, or yeah, the vertex, the y value. All right, for the axis of symmetry, what we're going to do is we're going to take the roots, 3 and 7, we're going to add them together, and then divide by 2. So x equals 3 plus 7 divided by 2. So 3 plus 7 is 10. 10 divided by 2 is 5. So x equals 5. From here, we're going to go to our vertex. We take this value of 5 and plug it in for the x. And to find the corresponding y value, we plug it into the function. So I don't have enough room. Actually, I have some right here. So I have 2 times 5 minus 3, 5 minus 7. And then I'm going to work this out a little bit. So 5 minus 3 is 2. 5 minus 7 is negative 2. So we're going to multiply these out. 2 times 2 is 4. 4 times negative 2 is negative 8. All right. This table is very difficult to see for me. I'm pretty sure it is for you as well. We're still going to put the vertex in the middle. So 5 comma negative 8. So the number's getting bigger. 6, 7, 8, 9, 4, 3, 2, and 1. Okay, so I'm still going to use the 1, 3, 5, 7 rule, but I also already know things here. I know that 3 comma 0 is 1 point and 7 comma 0 is another point, okay? So those are things you can do. And honestly, for intercept form, these 3 points, so 5 and 5, 6, 7, 8, so 5, negative 8, 3, 0, 1, 2, 3, and 7, 0. I mean, 3 points is pretty much enough to make a parabola, but I add the extra points to make the line smoother. Okay, from here, let's draw the axis of symmetry. Okay, so 1, 3, 5, 7. My A value, this case, was 2, so A value is 2. So I multiply each one of these by 2. And we're going to see this probably goes off the graph pretty quickly. So from the vertex, right 1, that's a positive 2, so up 2. Right 1, up 6, and 1, 2, 3, 4, 5, 6. That point was right. Right 1, and then up 10. And that's as much as I can do. So I can do this here. So this graph is vertically stretched by 2. That's why it looks elongated. Oop, it should be right here, shouldn't it? Yeah, there we go. And let's see if I can get this point. And sorry about this extra point there. And there we go. Okay, so we have 6, negative 5, negative 6. We have the zeros, and this is the tens. And for the next one, I know I just add 14, just like I did in the previous one. So 10 plus 14 is 24. And I guess it just happened to work out that way. Or what I still did in a previous problem. Okay, so I have all that there. Now, one thing that we may ask you to do, and actually not we may, we will ask you to do, is to convert it from intercept form to standard form. So if you think about vertex form, you had to write x minus h twice, and then you fold it out, multiply by a, and then add to the k. So this one is pretty much the same thing. So what I'm going to do here is FOIL out the parentheses. So x times x is x squared. X times negative 7 is negative 7x. Negative 3 times x is negative 3x. And negative 3 times negative 7 is positive 21. So we have x squared, combining like terms, negative 10x plus 21. And the last thing I'm going to do to convert to standard form is just distribute the 2. 2 times x squared is 2x squared. 2 times negative 10x is negative 20x. 2 times 21 is 42. And that's how you convert from intercept form to standard form. So both of them are pretty much foiling, right? The intercept form you see, the vertex form you have to write it twice. If you want to do the domain here, it's just like the previous one, still all real numbers. The range, bottom, which appears to be -8, and it heads towards infinity. So you see a lot of these, they're quadratic functions, so it's pretty easy to do them all the same way. All right, so for here we have, it says to graph a quadratic function in intercept form. So I'm just going to go through the steps like I did the previous problem. So when I start with these, the first thing I'm going to find are my x-intercepts, or my roots. So it's an intercept form because it's x plus 3, x minus 1. So it's x plus p, x minus p, x minus q. So the opposite of this, since there's no value directly in front of x, that's outside the parentheses, opposite of 3 is negative 3. So my first root is negative 3, 0. My second one, the opposite of that would be 1. Then I do the axis of symmetry. And if you recall, that's x equals p plus q divided by 2. So you take the average, right? Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. Now to find the vertex, we plug it in. So let's go ahead and put 2 times, let's see, negative 1 plus 3. And then negative 1 minus 1. So 2, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. So x value is still negative 1. That's the axis of symmetry. And hopefully you can multiply this out to get negative 8. All right, from here, if you want to do some of the other stuff in the previous problem, so the direction, if we look at the a value, it is positive, so it opens up. And the roots, we already have those there. So let's go to make this graph. So 1, 0. Negative 1, negative 2, negative 3, 0. My vertex is at negative 1. 1, 2, 3, 4, 5, 6, 7, 8. All right, and I can do the 1, 3, 5, 7 rule. 1, 3, 5, 7. A value is 2. So we go right 1, up 2. Right 1, up 1, 2, 3, 4, 5, 6, which we did. And then right 1, up 10. And this one, up 2, up 6, up 10. I draw my axis of symmetry. That just kind of makes a little guide for me to draw a little bit straighter, even though that hook was not very good, but I did try. So there is my graph from the intercept form. All right, moving on to these application type problems here. So it says the path of a place kick football can be modeled by this function here. Now this one, let's talk about it. It says y equals negative 0.026x, parentheses x minus 46. This is a quadratic function. How do I know that? Because this x on the outside, if I multiply it, x times x is x squared, okay? So whenever I think about this x, I can also write it as this x minus 0, if that, or x plus 0, it really doesn't matter. Like, that's something you can do if it just helps you to see that it's in intercept form. But let's kind of talk about this. So this x by itself, this is why I tell you to always set it equal to 0 and solve it. Like the x minus 46, you can literally see when you solve it, you get x equals 46, right? You add the 46 over and you get 46. But this one right here, if you just set it equal to 0, then you get your x-intercept right there. You can already see that x is equal to 0, okay? So that's why I always set it equal. So if you just have a single x by itself on the outside of parentheses, then the automatic intercept will be 0. So for this one, since it's 0, I'm going to assume this is where it starts off from 0, 0. The 46 is the distance down where it lands. Okay, so that's what these are. So the path of the foot is kicked is placed here, where x is the horizontal distance and y is the corresponding height in yards. How far is the football kicked? Well, we started our first x-intercept at 0, 0, and then it landed 46, 0. So this ball traveled 46, and the units here is yards. What is the football's maximum height? So we're looking right here. Where is its maximum height, which is going to be our vertex, right? So well, first thing we need to find is the axis of symmetry. X equals P plus Q, so 0 plus 46. And we divide that by 2. So it is equal to 23. Now for my vertex, I have 23, which is pretty obvious because we can understand the vertex is in the middle, so that's 23 yards in the middle between 0 and 46. But now we need to find that y value. And I may need to use a calculator here, so let's see. So we're going to plug it in. So y equals negative 0.026. This is 23 for x, and then 23 minus 46. All right, so here I don't actually have a calculator, so I'm going to go ahead and use Desmos real quick. So let's see if I can just plug this in here and get this right. So let's move that up. All right, so we have negative 0.026 parentheses 23 close parentheses 23 minus 46 close parentheses. So yeah, that looks right. I'm just gonna hit enter, and it tells me 13.754. So you can see that there, 13.754. So this is 13.754. So for part B, the maximum height was 13.754 yards. Okay, so there we go. And then these last three problems here, pretty much I'm just gonna run through a few things on these again really quickly, just to kind of wrap it all up together. So it says graph a function, label the vertex, axis of symmetry, and x-intercept. So let's go ahead and see how I did. So I'm gonna do number, it doesn't matter, 5 and 7. The A value is 1, so it'll be quick to graph. So first, I can find the x-intercepts here. Opposite of that is 3. Opposite of that is 7. So 1, 2, 3, 0, 4, 5, 6, 7, 0. So those are my two x-intercepts. So one right here, one right here. Axis of symmetry, x equals 3 plus 7 divided by 2, which is 10 divided by 2. So x equals 5. Okay. So right here. And most of y'all could probably just see that that was in between. The 5 was right in between. And the last we're going to do is a vertex, 5, comma. So here we're going to do 5 minus 3. So I'm plugging them into here. 5 minus 3. And then 5 minus 7. So this is 5 minus 3 is 2. 5 minus 7 is negative 2, which is negative 4. So 1, 2, 3, and negative 4. And here that's all it's asking me to do is do those. So there is my graph. I'm just using 3 points. I prefer a couple of more just to make it smoother, which I mean it should have just been here and here, but it's fine. So this is my axis of symmetry. This was my vertex, and these were my X-intercepts. Okay, so number 7, I'll do this one just as quick. So first off, X-intercepts. So here, opposite of that is negative 1, 0. Opposite of that is 5, 0. So negative 1, 0, 1, 2, 3, 4, 5, 0. From an axis of symmetry, like I said, 1, 2, 3, 4, 5, 6. So 1, 2, 3. I can tell that it's probably going to be right here, but I am going to do it algebraically to make sure I am right. So from axis of symmetry, x equals negative 1 plus 5 divided by 2, which is 4. And 4 divided by 2 is 2, which you can see it is x equals 2. And then last, for my vertex, I know that 2 is the x value. You're going to plug them in, so you have a negative sign. Then you have 2 plus 1 times 2 minus 5. So that's going to be negative, and then we have 3 and negative 3. So negative 3 times negative 3 is positive 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the graph is facing down because the a value was negative. And once again, I could have made this a little bit smoother, but that's pretty good there. All right, and those are the notes for graphing quadratic functions in Intercept Form.